Hi there. My name is Matthew, and our group project focuses on the northwestern portion of North America, the mountainous region known as Alaska. It is home to many geologic features that we will soon get into. As we cover the different geological aspects of this region, we will include many of the featured national parks and how they related to the topics at hand, including the anthropogenic influence of recent history. The national parks here within this region paint a wonderful picture of how Alaska formed, the secondary processes that took place, and what could be expected in the future. Alaska, being heavily influenced by plate tectonics, is home to various landforms such as volcanoes and large mountain ranges, to glaciers that run many miles long. As you can see in the map to the right, Alaska features numerous mountain ranges that make up the landscape. Some of the ranges that can be found within national parks include the Brooks, Alaska, and Aleutian Range. The topography throughout Alaska is all above sea level, ranging from 300 meters to 1,500 meters. We will now get into Alaska in a much more depth manner, looking at the geological history as well as the history of the national park establishments.
Hi, I'm Carlos, and all the parks except Denali and Katmai were established on December 2nd, 1980. The national parks include Kenai Forge, Lake Clark, Gates of the Arctic, Glacier Bay, Wrangell St. Elias, and Kobuk Valley. Denali, as seen on the photo on the right, was established on February 26, 1917, and Katmai was established on September 24th, 1918. Under the Alaska National Interest Lands Conservation Act, a significant conservation law designed to safeguard the vast expanses of land in Alaska, encompassing national parks, wildlife refuge, and other public lands. This was passed on December 2nd, 1980. Primary landowners during the 1700s consisted of natives such as Eskimo, Aleut, and Indian tribes. They controlled the Russian trade posts all throughout Alaska until 1867, when Russia sold the 375 million acre land of Alaska to the United States, and ultimately becoming a state in 1959, as stated by the Alaska Department of Natural Resources.
Hi, I'm Amanda. The Department of Geological and Geophysical Surveys conducted research finding that the majority of Alaska's bedrock is composed of metamorphic rock that is around 1 billion years old, with some rock reaching up to 2 billion years old. The northernmost portion of Alaska is older, and as you follow south towards the end of Alaska, it gets younger. The majority of Alaska was formed due to terrain accretion, which contributes to the growing mountains and younger terrain being on the southern end. The Yucatan terrain collided with North America 25 million years ago, and because it is still attached to the Pacific Plate, it is still merging with the continent today. The south-central part of Alaska, the Alaska Range, is home to Denali National Park, which is known for having Denali, also known as Mount McKinley, which has been forming since the Cretaceous period. Denali is rising at 1/2 of a millimeter per year and standing tall at 20,310 feet. Denali is the tallest mountain in North America. Denali sits on top of the Denali Fault and Hinds Creek Fault system. Both are strike slip faults, which contribute to its overall growth as a mountain. The most southern parks are located on the Border Ranges Fault, which goes from Kenai Fjords to Wrangell St. Elias all the way to Glacier Bay National Park. Katmai National Park is located near the Bruin Bay Thrust Fault. Lake Clark National Park is located on the Lake Clark Thrust Fault and the Bruin Bay Fault. Two of the national parks are located in the Arctic Circle, which is the northernmost part of Alaska. The first being Gates of the Arctic National Park, located in the Brooks Range, which is surrounded by multiple thrust faults. The second is Kobuk Valley National Park, which lies on the nearly dormant Kobuk Fault. Alaska has a long history of volcanism, so much so it has its own Alaska Volcano Observatory, which was founded in 1988. Within the borders of many of these parks, there have been active and dormant volcanoes. In and around Alaska's national parks, andesite is a commonly found rock near subduction zones and volcanoes. Near the southernmost part of Alaska, you can find the northern portion of the Ring of Fire. Along the Ring of Fire is the Aleutian Arc of Alaska, which is a chain of mostly active volcanoes that were created due to the subduction of the Pacific Plate beneath the North American Plate. In the state of Alaska, there are 130 volcanoes, with 54 being historically active, per the study done by the Alaska Volcano Observatory. The photograph on the top right is of the eruption by the Redoubt volcano in Lake Clark National Park, which occurred on April 21st, 1990. Prior to the eruption, there were 23 explosive events that occurred between December 1989 to April 1990. Some impacts these volcanoes may have in the parks include limiting access due to volcanic ash fallout, lahars, which are common due to volcanic debris mixing with ice and snow, pyroclastic flows, lava flows and domes, and volcanic gases such as sulfur dioxide.
When regions have active volcanoes, natural disasters are bound to occur. Volcanic activity is common throughout western and southern Alaska and can happen at any moment. Earthquakes are extremely common throughout the southern region as activity typically falls near the subduction zone. Tsunamis occur when other natural disasters such as earthquakes, landslides, and volcanic activity occur, and Alaska happens to be particularly vulnerable as it is one of 5 states in the US that has them. The bottom left image shows the wave amplitude of the 1964 tsunami that occurred in Alaska and reached areas such as Hawaii and British Columbia. Alaska's landscape is heavily influenced by glacial activity as U-shaped valleys, fjords, till striations, and many more features are directly associated with glaciers. Climate change has severely impacted the rate at which glaciers melt as they have shrunk 8% from 1950 to the early 2000s. Glacier Bay National Park features over 1,000 glaciers as seen on the map, which have accumulated over the last 3 million years and have formed many different landforms as well as eroded rock and debris through glacial melt and glacial movement.
Kenai Fjords National Park, Wrangell St. Elias Mountains National Park, Glacier Bay National Park, and Katmai National Park are all known for their glacier ice caves. In addition, the Root Glacier in Wrangell St. Elias, which is the nation's largest glacial system, contains many ice caves that get bigger due to creeks melting out the glacier from the inside. Ice caves trap the cold air inside the glacier, which helps keep them solid year-round. On the lower right side, pictured is an ice cave pillar located in the Brady Icefield in Glacier Bay National Park.
In the gates of the Arctic National Park, the Agritech peaks, as seen on the left, are made of granite and surrounded by a schist metamorphic rock. The park's base is mostly sedimentary rocks that formed millions of years ago on the ocean floor. The Great Kobuk sand dunes, which are remnants of the Ice Age, look out of place when seen. The Kenai Forge contains layers of dark-colored mud, sand, and gravel that eroded from an ancient shore that were deposited by underwater landslides into the sea. These sediments were slowly transformed into sandstone, mudstone, and conglomerate rock assemblages under heat and pressure. According to the geology of Glacier Bay National Park, it is home to limestone layers with seashell fossils, suggesting that they formed in shallow, warm waters near the ancient tropical islands. Denali features rock formations and fossils of ancient creatures that traveled thousands of miles to the area from ocean depths. This is according to the Denali National Park and Preserve. According to the geology, Wrangell St. Elias Park has a diverse makeup of terrains representing pieces of old continental crust, as well as oceanic crust and volcanic island chains that formed in the open ocean. In the southern portion of the park, east of Lake Clark, sedimentary rocks and metamorphic rocks of the Mesozoic age dominate, while the northern half features tertiary and Mesozoic intrusive rocks. According to the geology of Katmai National Park and Preserve, the bedrock in Katmai is composed of sedimentary rocks of the Jurassic, Cretaceous, and early Tertiary age, intruded by Jurassic and Tertiary igneous rocks.
Fossils are found all throughout Alaska and can be dated as far back as almost 600 million years. Fossil remains of trilobites, echinoderms, and brachiopods can be dated as far back as 500 million years ago and can be found in sedimentary rock from the Cambrian period in national parks such as Gates of the Arctic. Dinosaurs such as Pachyrhinosaurus, Nanoxaurus, as pictured at the top, and Hadrosaurus would thrive in this region for a while until an extinction event occurred 65 million years ago, where the climate grew colder and colder all the way up until around 2 million years ago. Fossils are a great way to learn more about paleoclimates in a given region. Fossils of ancient pollen, soils, and other macrofossils were found near Denali National Park, indicating that the dominant type of vegetation within that area was a boreal forest, meaning that the precipitation levels were most likely higher than today. This included forests and swamps in between mountain ranges with very to little no bodies of continental ice to be found on Earth, let alone Alaska. Dinosaurs would roam the wet valleys in between mountain ranges as rain would soak the ground. Although these paleoclimates can be compared to present day environments, the human impact on climate change is affecting Alaska's current climate at a rapid pace.
According to our changing national parks, it is estimated by 2100, Kabuk Valley National Park will increase in temperature, with an annual average temperatures potentially rising by 9 degrees to 18 degrees Fahrenheit. Although it may not seem like a lot, an increase like this really harms Alaska. In case of the Arctic, the Weather and Climate Resource Brief Arctic Network trends in average annual air temperatures in Arctic Alaska from 1950 to 2021 shows a substantial increase of over 3 degrees Celsius in communities near the national park. Over the past decades, the average temperatures in Kenai Forest has risen by 2 degrees Celsius, potentially leading to an increased glacial melt that could impact wildlife in Kenai Forest National Park. In Glacier Bay, the thawing of permafrost, which is essential to the northern Alaska landscape, has increased, releasing stored greenhouse gases and causing erosion, landslides, and damage to infrastructure. Recent climate warming has already had observable effects on ecosystems, such as reduced snowfall in spring, earlier snowmelt, shorter seasons of river and lake ice, and thawing of permanent snowfields, negatively affecting the Denali. Similar to other regions in Alaska, Katmai National Park is being affected by climate change. This includes changes in snow cover, lake ice cover, and glacial thinning. The Malaspina Glacier, as seen on the left, the largest glacier in North America, covering 1,500 square miles. Due to warmer and longer winters, more intense melting seasons, there is a risk that natural resources may be lost in the future.
Alaska is full of beautiful landscapes and complex geology that is still being studied today. The unique landscapes allow for the guest to experience amazing trips to all of these national parks located throughout the region. Although anthropogenic climate change has impacted Alaska in a number of ways, there is still hope to turn things around and begin to work towards building a sustainable future that can benefit wildlife, natives, and guests that want to enjoy these national parks.